2-7, Inverse Functions, Day 1. Your learning goal is that you will be able to build functions that model relationships between quantities from existing functions. In this lesson, we're going to learn how to verify inverse functions and how to find the inverse of a function. So we've been working with functions, which we've represented as f of x. And when you're talking about an inverse, that means that the x and y coordinate switches. So this is the notation for inverse. And we use this symbol, f inverse of x. So if our ordered pair for our function was xy, the inverse would be yx. So the x and y switch. X and y values switch. And to verify that two functions are inverse, we're going to use what we did in the last section. So that means you're going to show that f g of x is always simplifies to x or equals x, and because you have to show both, g f of x is also equal to x. So that's how you verify if two functions are inverses. You have to do both. So example 1, we're going to determine whether each pair of functions are inverses of each other. So for example 1a, we're giving f of x equals 3x plus 2, and g of x is equal to x minus 2 over 3. So remember, our job is to find f g of x and show that it equals x, and g f of x and show that it equals x. All right, so let's do f g of x. So we're going to take x minus 2 over 3 and plug it into the f function. So it'll look like this. 3 times x minus 2 over 3. And we still have that plus 2 on the end. So over here, my 3's cancel. And you're left with x minus 2 plus 2. The 2's cancel, and there you verify that side. Okay, over here, we're going to plug f inside of g. So it'll be 3x plus 2. So that's the f. And it's still minus 2 all over 3. Now, it's very important that you do the numerator first. So the 2's will cancel. And then you're left with 3x over 3. The 3's cancel. And if both work out to equal x, then you can say, yes, they are inverses. Okay, example 1b. Remember, we're going to check f g of x to see if it equals x, and g f of x to see if it equals x. All right, so we're going to plug in g inside of f. So I have x plus 3 over 7. Well, in this case, nothing cancels. So you're just going to have 3x plus 9 over 7 minus 7 over 1. So I'm going to get a common denominator. because I can't subtract that. Multiply this by 7, this by 7. That's going to give us minus 49 over 7. And combining like terms, I'm going to get 3x minus 40 over 7. So this one did not work. And then checking over here, because you have to check, I'm going to plug in 3x minus 7. Then we still have plus 3 over 7. Nothing cancels. You can't cancel the 7s. So you have 3x minus 4 over 7. This one does not work. So then, if that case, we write no, they are not inverses. Okay, example 2. A, we're going to find an equation for the inverse. And remember, this is the symbol. That means inverse of f. And B, we're going to verify that the equation is correct. Okay, so when you're finding the inverse, there are steps that you have to do. So first, let me give us a function. Okay, step 1 is to replace f of x with a y. Because remember, inverse means that the x and y have to switch. So in order for them to switch, we need a y and an x. So I'm going to do that first. Okay, step 2. Interchange or switch the x and the y. So this is going to be x equals 7y minus 5. Step 3, solve for y. So I'm going to get y by itself. So I'm going to add 5. And then I'm going to divide by 7 on both sides. So you can just leave it as y equals x plus 5 over 7. Step 4, replace the y with the inverse symbol. So remember, I changed it in the beginning. So this is the inverse of f equals x plus 5 over 7. And here is your inverse. So these two are inverses. So this was letter A. Now let's do B. Okay, for example B, we are going to verify that the inverse that we found is truly indeed the inverse. So we're going to do f of inverse. So we're going to take our inverse function and plug it in for our f. So it's going to look like this. 7 times x plus 5 over 7. And we still have that minus 5. So this 7 and this 7 will cancel. And then I'm left with x plus 5 minus 5. The 5's cancel. And there's my x. So I verified the left side. Now on the right, we're going to take our f function, our original, and plug it into our inverse function. So it's going to look like this. On the top, we have 7x minus 5. Let me use yellow. And then we still have the the plus 5. And this is all over 7. You have to do the numerator first. So the 5's cancel first. Then you're left with 7x over 7. The 7's cancel. And there's your x. So now we verified that our inverse function was correct. And make sure you show each step. Just a note, if you ever have to solve for y and you have a cube, you're going to cube root both sides. So these are just helpful hints. Helpful hints. If you ever have to solve for y and there is a square root, then you would square both sides. So it'll look like this. So this just helps you, whatever your root or your radical is doing or your exponent is doing, you always do the opposite. And that concludes the lesson.